Kahl is a researcher at the K. Lisa Yang Center for Conservation Bioacoustics at the Cornell Lab of Ornithology and Chemnitz University of Technology. With a background in computer scientists, we invited him because of his great work as the lead developer of WOPAM, a leading research and citizen science platform that identifies around 3,000 bird species by sound. The platform has also been used for other taxa, expanding its potential for broader biodiversity monitoring. And we are so excited to have Stefan with us today to share his insights and discuss the critical role that open source models and tools play in scaling acoustic monitoring efforts globally. So Stefan, over to you.
All right, thank you so much. Thank you so much for having me. And it's really great to see that so many people are interested in AI for conservation. And I'd like to talk about how AI-powered tools can actually contribute to biodiversity conservation. And so I'm pretty sure the audience, like among the audience, everyone has seen this graphic, which, is from the paper Bending the Curve of Terrestrial Biodiversity. And I'm pretty sure everyone is aware that there is a biodiversity crisis. And we need to bend the curve. And then even the Cornell Lab, part of the mission of the Cornell Lab is contributing to bending the curve. But the thing is, there's no way that just a single institution can actually, at least even make a dent. And so I think it's paramount to just be aware that when we talk about bending the curve, we have to do it together. Like everyone has to be involved. And in order to do that, we need tools that are openly available, that are accessible. And that's what I'm going to frame my presentation around. And so the things I'd like to talk about is how we can maximize the impact, or at least how we think we can maximize the impact of open source tools for conservation, and then what we think should be done to build models for applied ecology. And by models, I mean mostly AI or machine learning models. All right, so talking about these open source tools, I'd really like to introduce what I call like the BirdNet story. Just to summarize, I think if you're aware that, so we're hosting this software tool called the BirdNet Analyzer. It's freely available on GitHub. And I believe, among others, it's one of the most sophisticated tools to do bioacoustic analysis at large scales using AI. And it really started as a dissertation project. And it was just it was like a single person, me, working on a model, trying to figure out how to do that using CNNs, using a vision model, as Justin mentioned. And I published it just because it was kind of on vogue back then in 2019 in the computer science community to publish papers with code. So it was kind of expected to publish the models and the code so that people can run it. And people actually started using it. So that was great to see. And so I kept adding new models. Published a new repository that had a few examples and the newest models. And then, oh, wow, well, people complained because that already introduced some breaking changes. People were used to the interfaces that we built with the first repository, and now we're breaking things. And that's something we hadn't anticipated. That, okay, we hear you. Let's go back. Let's implement the command line interface so people can actually develop their own processing pipelines. So that was like the initial intent, is put the model somewhere and let people build their own pipelines. But as it turns out, and that's something that we needed to learn the hard way as computer scientists, is ecologists don't use CLIs, or they don't want to. And if they don't have to use command line interfaces, they will happily use something else. And that's when we started to implement a graphical user interface and add this to the analyzer, add this on top of the models. And then we kept iterating over it and adding more and more features. And then it really took off. But I think the one thing that really dramatically changed the trajectory of BirdNet and how it's been used is that we introduced a no-code environment to allow people to train their own models. And I think that was the breakthrough invention. So thinking about bending the curve and building tools that are open source and that can contribute to biodiversity conservation, I think there are different dimensions or aspects. And as a computer scientist, and this is solely speaking from a computer science, data science perspective, you're mostly building things for developers. You publish your models, your APIs, your microservices, your documentation on GitHub, and it's that's the technology part, and that's what we're good at, that's what you're trained at. But there's the other side, there's scientific research that's mostly carried out by ecologists, and if you want your models to be applicable to the research everyone else is doing, you need to publish applications. You need these no-code environments so that people who don't have a formal CS background can actually use these. You need reliable services. You need frameworks that are adaptable and easy to use. And then you have to publish papers on it because ecologists rely on peer-reviewed work. And then in between, there's even more, and I think that's something that we focus on at the K-Lisa Yang Center for Conservation Bioacoustics. That's engagement. You have to engage the general public because it takes everyone to bend the curve. You do this mostly through community projects. That's citizen science. These are apps like our BirdNet mobile apps, competitions that we're hosting, for instance, on Kaggle, hackathons, public events, social media, and all that. And that builds on top of like the things you have to do as a computer scientist. And then even if you talk about capacity building, like educating people through dedicated curricula, educating local institutions, allowing them to carry out their research, doing that through summer schools, tutorials, videos, or classrooms. That's also part of like the story of that's part of like this holistic approach of building open source tools for biodiversity conservation. And if you're a computer scientist, that can feel a bit scary, right? Because you thought, oh man, I thought I was like deep learning engineer, and now I have to do all these other things. Now I have to think about like what ecologists need. How do I like even come up with a curriculum to teach local groups? And so that's something that plays into, and I think there's a the mindset of computer scientists that has to change if we think about building these powerful models and even more powerful models moving forward. And as Justin mentioned, right now we're relying on technology that has been established. We're using mostly vision models, but we've seen large language models that if if we talk about foundation models, like the things that are at the core of everything that we do with AI, the things that can do everything, there are some considerations that we have to make, and there are some things to consider what it means like for distributed tools and public tools. And I think we can all agree on that foundation model for bioacoustics. I mean, okay, cross taxa, a broad frequency range, different inputs, like all the species, mega detector, like anything that could possibly occur, maybe even include like metadata, maybe even image, maybe even language. So like I think there's consensus on okay, that's what it takes. Massive amounts of compute, large models, that's a foundation model. But I believe there's more to it, and there are some challenges when thinking about applying these models for ecology, for nature conservation. And so usually the process, or at least how I view it is, as a computer scientist, as an AI engineer, you start with the model development and then you open source it. So that's the story. So that's the plan at least. And usually what happens is you have the funding to do the model development, and then everyone expects to like the open sourcing to happen on the side. And that's usually what they call the last mile. It's just like, yeah, like some easy steps at the end. But I believe like thinking about all these different dimensions, thinking about APIs, services, applications, competitions, social media, tutorials, videos, there's so much more that comes after model development, which is usually underfunded. And it's usually not like the core competence of computer scientists, but that's something that has to change. And I believe AI engineers have to adapt to these requirements and maybe then even cut down on the amount of time or the resources they invest into model development. And so to wrap this up, I think there are a few considerations when thinking about building powerful models that everyone can use, building distributed tools, building tools that are open source, that are publicly available, and that actually contribute to nature conservation. And I think, and I'm always a strong advocate of this, that the most important aspect of it, that applicability beats accuracy. And I think it is okay to sacrifice some percentage points in accuracy to increase the applicability. And I just want to like briefly mention a few things that I mean when I talk about applicability. I mean, for instance, that models need to be portable. So right now, for instance, in BirdNet, it was trained in Python with TensorFlow, but there's also a JavaScript version. So we made it so that we can convert BirdNet from Python from one programming language to another, which then supports a complete different set of hardware. So you can run BirdNet in a browser, which is cool. But one of the things, it was trained in TensorFlow. Open Soundscape is in PyTorch. There's no way to convert TensorFlow model to PyTorch, at least not with BirdNet. And so like we can't support Open Soundscape, which is unfortunate. These models, I think, need to be efficient. You have to think about like dedicated hardware, like microcontrollers or like devices that are super power efficient, and they need quantized versions, which will decrease the accuracy, but will contribute to the applicability. Models need to be customizable. I mentioned these no-code environments that colleges like to use to retrain for their target species. That's important. That needs to go into like considering what the architecture should look like. And then something that is super important is consistency. Um, Scores need to be consistent, need to be reproducible. That's something people need to be able to go back and reproduce results. And then also thinking about the last mile, you need sustained funding. You need to update, you need to provide bug fixes, you need to troubleshoot, and that's something to consider when applying for grants and for funding. And if you're interested in how we do it with BERTNet, how we proceed, if you want to contribute to the discussion or have ideas or features that you could think of, let us know. Make sure to go to bertnet.cornell.edu. And then thanks for listening, and I'll hand it off to the next speaker. Thanks.
We're going to stay on you for just a second.
Sure.
Thank you so much. That was an awesome talk. And I just wanted to take the opportunity. I've dropped this in the chat, but when you talk about all of the funding being for model development and then this stretch of like the last mile, all of the other stuff that it takes to make it open source or usable, I think we see that again across all of conservation. And it's shocking me that what's not shocking me, but like the last two sessions, all of the conversation has been around funding and funding infrastructure and funding that last mile. So I wanted to flag that we have a funding opportunity through WILDLABS that came out on Monday called the Boring Fund. And the goal is to fund the boring stuff of conservation tech, which means everything in that last mile, technical debt, training, developing documentation, doing all of the stuff you've just talked about. So that funding opportunity is open. We know it's small, but we're hoping it is the start of having actual resources to this sort of foundational, like last mile stuff. But so there's a link in the chat if you're interested in that. But I actually wanted to throw you, Renata, you had such a great question. I want to actually throw to you to be able to ask that to Stefan. Would you be able to jump in? Do you have a mic? Okay, I'm going to ask Renata's question for her. She says, large amounts of data and computing power equals resources. How can we be more inclusive to allow researchers from less resourceful countries, and usually more biodiverse, to tap into the resources with equitability? Should we be investing in data centers and further capacity building in the global south? What do you think?
I think the best way to scale is to be mindful about the resources a model needs to be run. And that, like, even if you assume, yeah, they're gonna run it in a cloud environment because they have their cloud, eventually AWS costs will eat you alive. And so that's just something that's not sustainable. And so even if you throw all the compute that you have at these models, at some point it's not going to scale very well. And so that's something we try to be mindful about, like make sure that these models run on low, like on low resource PCs or workstations, maybe even run on embedded devices like Raspberry Pis, which might even be more affordable in low resource countries. And so I still think there's a difference between training a model and then running it. Running is usually cheaper and like can be done like really quickly, and even the retraining process doesn't need a whole lot of resources. It's the big model. It's the training of the big model that is like requires a lot of resources, but we can make sure that we do have the resources to train it and then deploy it and make sure that everyone can use it independent of these resources. So I think that's the best way to scale it. I'm not sure if everyone should own a data center. I'm not a huge fan of data centers per se. I think if people have an old laptop, they should be able to run BERTNet. That's at least something we're striving for, is like they should be able to run it even on outdated or low resource hardware.
Filippo, do you have a mic?
Yes.
Do you want to ask your question?
Yeah, absolutely. Hi, Stefan. Thank you so much for your talk. It's super interesting. I was very curious when you said that the turning point happened when you implemented a retraining feature, because I heard sometime that automatic retraining might be problematic when the users don't have experience with machine learning retraining due to the quality of annotations, the parameters set for training, the dataset split, and all of this. Do you have any insight on this issue?
So that's still true. It's still complicated, and you have to be cautious about the data and data curation. But that's usually something that ecologists are really good at. They know their data, they know their species, they have these collections, they're clean. They've went through thousands of hours manually, and they have like a nice setup. So like they usually like ecologists, at least that's my impression, do have the data and they're also scientists, so they know like what a good scientific practice is that you do experiments and all. Sometimes people struggle with their mental models of what the AI does, and that's on us doing a better job in explaining what all these different settings are and so like what these hyperparameters are. So like it's still like a complicated process to train, even though you only have to click a few buttons. I'm not sure if you can abstract this away, but that's, I think, something that has to go into the capacity building. That's what we're trying to do, is educate people on these processes, educate at least on a higher level on what the AI does and what the model sees, it's a vision model, right? And what it does and how it works and what a score is, what the metric is. So these things are still there, but I think one of the largest contributor to a successful model or good model is data curation in a clean or like at least a representative data set. And that's usually something people have.
Okay, there's a lot of questions coming for you specific to BirdNet in the chat. So I'm gonna get you to jump into the chat and pick up some of those questions. And there's also just like a lot of like, thank you for developing BirdNet and kudos. So thank you for that wonderful talk. Gave us a lot to think about. I'll bring you back for the group discussion in a second.